All right. So there's how we set it up. Hopefully some of you started the algebra. What is your first step here? To get what off the bottom?
R2.
To get r off the bottom, right? It's not r2, it's r. R squared. It's a little different than 2r, right? Okay. So how do I get r squared off the bottom?
Just times it by.
Multiply the top of both sides by r squared, right? You could just flip them, but then we're going to have to divide over and go from there too. Okay? So multiply the top by r squared. So then this r squared gets canceled, right? Right? So then we have 7.357 times 10 to the 30th r squared equals 6.67 times 10 to the negative 11th times 3.3 times 10 to the 23rd times 1.99 times 10 to the 30th. Right? Yeah. What zero?
The very first 10 to the power.
Oh, thank you. I almost did it again. Thank you, Kevin. Now, if you want to, guys, instead of writing these the whole time, you could multiply those through before doing the algebra. But that's okay. So, now what do I do? Divide by that, right? Right? So we have r squared over here. Now here I'd actually do that calculation instead of just carrying those numbers with me everywhere I go. All right, so let's figure out what that is. So 6.67 e negative 11 times 3.3 e 23 times 1.99 e 30 divide by 7.357 e 30. And I got 5.95 e 12. Or times 10 to the 12. Okay. Yes.
Is that negative 5.9?
Nope. 6.67 is not a negative number. It's a positive number. Okay? It's the x one that's negative. Okay. Let's see if that makes sense. The 30s cancel each other out. 23 minus 11 is 12. I got 12. Perfect. Right? Works out. Does that make sense?
Yeah.
So now what do we do? Square root. I bet we're going to have a power of 6 at the end. What do you guys think?
2.4.
Okay. Your calculator gives you 2.440034.95, okay, in meters.
2.4403.95.
Yeah. Do we have to write it like that, or can we write it as a power?
Right out of the power.
1, 2, 3, 4, 5, 6, right? 2.44 times 10 to the 6th meters. Does that make sense? Does that make sense, guys? Okay. And we can look on page 173 of our book if you want, so we can check our answer. Say the radius of Mercury, 2.44 times 10 to the 6th. You can hold your applause. You don't need it. I said you can hold it. Okay. All right. We got 5 minutes left. We can do one more. Yes, we can. Your desire to do physics is deep within inside you. I know that you want to do it. Right? All right. Oh, we can't see C. That's all right. Mr. Branch to the rescue. All right, here we go. A 500 kilogram satellite needs a centripetal force of 4,900 newtons to stay in orbit. Well, I forgot they don't need at or it. To stay in orbit around the Earth. How far above the Earth does the satellite need to orbit? So we're dealing with a very small mass now, right? A 500 kilogram mass. The Earth still has its mass. Anybody remember what it was? Or not?
5.9.
For the mass of the Earth? Okay, good. You're right. 5.97 times 10 to the 24th kilograms. We can round it to just 2 decimals. That's fine. All right. We know the force is
49.
good. I threw a little curveball here. I said it needs a centripetal force, right? What keeps the satellite in orbit? Gravity, right? So the centripetal force is gravity. Sergio, can you turn the heater off? Working up a sweat up here. All right, not just mental. All right, thank you, sir. And we're trying to find what? Radius again, right? So, oh, big G. Can't forget big G. You ever find yourself where big G is an unknown? Then that means you forgot what big G was. And big G is never unknown. Who was it again? You remember? No, not Kepler. Henry Cavendish. Come on now. When you guys go on Jeopardy someday, make sure you remember Mr. Branch. Henry Cavendish. That'll G. Okay. All right. Same way we did part B. We plug in, we solve for R, right? Okay, being that we have short time, 3 minutes. I think I'll do this one, and you guys follow along. How much time do I have left, Sergio? Oh, that's a challenge.
You got this.
Woo! Please stay in your seats until you are called down for the ACT prep stuff. All right, so that's our equation. Right now we're going to solve for R. Okay? Just to let you know, I will finish this, so if you want to stay and just be a little late to ACT prep, that is fine. Just don't tell Miss Bergman I told you so. All right? Now, what I'm doing right now is I'm actually plugging in the top part. Because remember I said last time I don't want to carry all those numbers through. I get sick of wasting pencil lead. So I don't want to write all these numbers through. So what I figured out was that top part is 1.99 times 10 to the 17th. Okay? And I have 4,900 over r squared. Now what should I do? Multiply by r squared. Sounds smart. Times makes sound like fourth grader, Sergio. Okay? So we multiply by r squared, right? So 4,900 times r, now I sound like fourth grader, times r squared equals 1.99 times 10 to the 7th. What do I do now? Divide. There you go, using good math words. So r squared equals 1.99 e to the 7 divided by 4,900. Yeah, E17, thank you. 4.06 times 10 to the 13th. Now what? Square roots. Second square root, second answer. I have a radius of 6.366.715. Right? Let's rewrite this. So 1, 2, 3, 4, 5, 6. So R equals 6.37 times 10 to the 6 meters. I beat you, Miss Bergsma.
Yeah.
Check that, Miss Perez. Any questions? Any questions?
Any questions, guys?
All right, have a good day, everybody.